recording, and then share our screen. And then yeah, so last time we were going over the this notes on transactions and locks. We're going to continue going over that today, finish up going over this handout and extension to the handout. That extension to the handout is just in the updated, I updated the notes.pdf file in the repo, so it's just a longer file now. And the stuff that's the new stuff that's extending the old stuff is specifically things that will be needed for next week's homework programming assignment. No programming assignment this week. You should have, I guess it's a lighter week, but also there's a lot of things with the locks to figure out and get straight, both for the quiz that will be next week, probably Wednesday. Assuming we finish everything today, the quiz will be Wednesday next week. And then the homework assignment will also, the programming assignment will also require that you understand all of this lock material. So that's what we're going to do today, finish up those notes. And before you do that, though, quick announcement about the midterm. Problem 4 on the midterm. I'm going to, I think I made a mistake grading people's problem 4, so I'm going to go through and regrade those. And hopefully that'll be done today. But yeah, you should know that that'll get updated. And there's also been a number of questions from people about extra credits, so I'll be posting an additional extra credit thing sometime this week related to boosting grades on the midterm. Any questions about any of that before we get started? Technical material? Yeah, those of you just coming in, there's a new handout in the back that extends the last handout. Make sure you get a copy of that. So today, so up here again, I've got our mostly the same sort of layout that we had before. With on the right-hand side, I've got the notes opened up, but now on the left-hand side, I have 3 terminal windows opened up instead of just 2. We're going to use that third terminal window to do a little bit of debugging, help us debug what's going on in our locks. So yeah, that'll be useful for us here. I'm going to start again by opening up our Docker containers. And so I'll just re-go through the whole process from scratch because there's a lot of things here that can trip us up maybe. So Docker run Postgres. Again, Postgres is the standard. Zoom out so we can see it all. Postgres is the standard image that Postgres runs on, just an empty database. In order to use this image, you have to somehow specify how people are going to log in. And the easiest way to do that is the Postgres host auth method, because we didn't specify any login. We're getting this error message. So Postgres run, and then -e for environment variable, like that. And I'm also going to add the -d flag, -d and -e, the D for daemon, so that it gets sent to the background. I hit enter. And now I'm going to run Docker PS. We have this one container running right here. In order to connect to that container, Docker exec, and then the hash, and then we're let's see. Today, so last time I connected to all of them directly with pSQL like this. Today I'll do something just slightly different by doing bash right here. And again, so I do this. You can see that nothing happened. It's a common mistake. Anytime you're doing an interactive Docker session, this is different from Docker Compose. Docker Compose does this automatically, but when you're doing just Docker, you have to specifically specify that you're doing an interactive thing. with this -IT flag, that I for interactive, T stands for the TTY, the terminal emulator. And now if I hit that, then it opens up bash and I can actually type things in. Another sort of quick pronunciation thing, I would pronounce, so anytime we have like these IDs, I often pronounce them id, because that's a little bit faster. This IT right here, I never pronounce it, because this I and this T are two like distinct concepts. The I is for interactive, the T is for terminal. And so they're not like, you want to make sure that they're always distinct in your pronunciation and you don't pronounce this it. It would be perfectly valid to do, instead of IT, do TI like that, and everything still works. So I only sort of slur my syllables together, slur my acronyms together when the things inside of them are actually semantically linked somehow, but here they're not. And then if I type psql like this, we get an error message saying that we can't connect, and the reason for that is because you have to specify a user that's connecting, and the default user is named Postgres like that, so now we can connect. Repeating that procedure on these other terminals down here, going into bash, and then psql -user equals Postgres like that. And down here, bash psql -user equals Postgres. And now I've connected all three terminals to the same Postgres session. Last time, so on the right over here, on our notes, so we're talking about these transactions. These transactions are a way to control how two different sessions are interacting with each other. And we're using these multiple psql sessions over here to demonstrate all of this. But again, in our next programming assignment, which we'll see starting Monday next week, we're not going to be using psql that's creating these two different sessions. It'll be Python that's creating these multiple different sessions. And so things will get a lot more complicated because it'll be both Python and SQL code mixed together. So at this point, it's just like, sort of the narrowed down to just like isolated examples that capture all the essence of all the problems. And then next week, we'll see more, it'll be more like example focused of like what's the purpose of all of this stuff. The right way to think about what we're doing right now is sort of like, if you're solving a Sudoku, you don't necessarily think about like what's the purpose of Sudoku. You just have these arbitrary rules that you're working through, solving the puzzle. At this point, just think of these as puzzles that we're trying to solve. And the starting next week, the why will start becoming more apparent. We can't really start talking about the why until we have all the mechanics fully worked out. Any questions so far? Let's see, how many people have, so we made it maybe about halfway through the notes last time. How many people have started looking, like reviewing the problems that we skipped over? A couple people. So again, your quiz on next Wednesday is going to come from these sorts of problems. And so you'll want to make sure that not only that you can follow along in class with the different explanations that we're doing, but that you can just sit down from scratch by yourself and work through these problems, because you're going to have to. You're going to be graded on that. Okay, so transactions. The key about the transactions was these begin and commit, or begin and abort or rollback blocks. And what we saw with, say, rollback, one of the key vocabulary words we had was this idea of, get my pen working here. Plug it into a different USB port, maybe. That's no good. Why are you not working? Okay, well, I guess we will proceed without the pen. But we had this key vocabulary word of atomic, the transactions make the code inside it atomic. So if we have 3 insert statements here, either all 3 of them happen or none of them happen. That's what the idea of atomic means, that it's either all or nothing. Another vocab word that I don't think we explicitly mentioned last time is the word isolation. And we saw the idea of isolation. The idea of isolation is that whatever happens in this transaction on the left is totally isolated from the transaction on the right, the session on the right, until we get to the, until we hit the commit. Then once the commit is finalized, once the atomic transaction has happened, then all of the other sessions instantly have access to it. So that atomicity, atomic, and isolation are sort of the 2 key properties of transactions that we've seen so far. In order to make our sort of transactions correct when we're doing more complicated things, so starting today, we're going to be talking about complicated inserts and updates and select statements and how they interact with each other. In order for those to be correct, there's this idea of locking of tables. And we started off talking about this idea of explicit locks with this lock table command. And when you do a lock table, then you explicitly specify what the mode is that you're locking in. So over here on our explicit locking documentation link, you're responsible for these 2 sections here, the table level locks and the row level locks, and the deadlock section. And the most important part of this is under the table level locks. We keep scrolling down. There's this table right here that tells us which locks conflict with each other. And so we did this problem 7 last time, where on line 3, we're locking the table in exclusive mode on session 1. And so because session 1 exclusive mode comes first, it is the existing locking mode, so the top up here, when we get to this lock down here, line 5. And we want to know on line 5, do we lock or do we not lock? And in order to understand that, we see that, okay, line 5, we're doing a share where our existing lock is exclusive. And so we come over here, existing lock, exclusive, our new lock, share, come over here, there's an X right here, so that means that we block, that we can't do the share lock until the exclusive lock is over. And anytime we're in Postgres and we acquire a lock for whatever reason, whether it's one of these explicit locks or an implicit lock, the lock will stay active until the transaction ends somehow. Either it's committed or it's aborted or rolled back. So here, this one is blocking because the share conflicts with the exclusive. And I think we did a couple of these examples. And yeah, so I'm not going to do any more of those unless there's any questions at this point. Any questions about that table, reading the table? This is all seeming familiar from last time, making sense? See some head nods. Okay, yeah. So yeah, again, like, yeah, I saw a lot of like head shaky, like kind of expressions too. And if the stuff that we were talking about last time seems weird and confusing and like both why do we care and like what the hell is going on, then that's an appropriate reaction because this is sort of, in my opinion at least, and probably most computer scientists' opinion, this is definitely one of the hardest concepts in computer science, dealing with concurrency issues. And the stuff that we'll be talking about today, it's only going to be getting like more and more confusing. So the best way to reconcile yourself with all this is just to work on all of these problems. Okay, so that was these explicit locks. And one of the main problems with locking, we said, is this idea of a deadlock. A deadlock is what happens when both sessions are locked against each other and neither session can make progress. So here, if we look at the table, we remember that an exclusive lock, locking in exclusive mode, that the name is suggestive that nothing else can lock inside of it because it's exclusive. And so if we have this this sort of interaction. This is the most common way for a deadlock to happen. Not the only way, but the most common way is when you have two different tables. And session 1 starts off with table T, session 2 starts off with table U. So this one is like linked to that. This one is linked to that. But then, so T starts off, session 1 starts off with T, and then it goes to U. Oh, and I drew my things backwards. That's what I get for not having a pen that works. Still not working. Oh, well, that's just gonna have to stay looking like gibberish, I guess. Sorry about that. But so here we have T then U, and over here we have U then T. That's sort of like the fundamental problem that's causing this lock, is that they're both relying on the same resources, but they're doing it in different orders, and so that's creating a deadlock. This is the most common situation for deadlocks. We'll see later today that in practice, the way this happens, most often the way that it's going to happen in your upcoming assignment is with unique keys. When you have that unique constraint, that's going to create this sort of situation. But deadlocks are bad. This is sort of the main thing that we should be keeping in mind, that if our goal is to insert data quickly, then when our systems stop because they can't make any progress because they're deadlocked, that's the worst possible case. So we're going to be trying to avoid these deadlocks. And then there's a bunch of different problems which provide, I don't know, different arrangements of the code to test which ones are going to cause deadlocks and which ones not. Yes?
I was thinking about like 14 and 16, where like one session when I was going to do it gets locked in session 1 at line 7, right? And then it will just be line 8, but then like session 1 is still blocked. Is that whole line be blocked then, or is that considered correct when you say like inserting or?
Okay, so let's just walk through problem 14 here. And so I'm going to use this middle pglocks session as session 1, this bottom one as session 2, and then this top one we'll be using for some debugging information. So in this middle one, let's go ahead and do a create table T a int. So I'm not being careful with my capitalization, but that doesn't matter in SQL. And then create table U a int. There we go. One of the things to be mindful of is that here I'm creating the tables in 2 different sessions. The main reason I did it this way is just to illustrate that you can refer to a table no matter which session it was created in. But on the quiz, they might not be created in different sessions. They might be created in the same sessions. It sort of doesn't matter. And in general, anything that's happening outside of these transaction blocks, it really doesn't matter which session it's going to happen in. It's only things when you have these transaction blocks where the difference between sessions matters. So this is line 1 right here. This is line 2 right here. Then line 3, let's do the begin. And then let's lock table T in share mode like that. Then line 5, begin a transaction in the second session, and we'll do lock table U in exclusive mode. And one of the things, very important thing to pay attention here, is that if we look up in the table about share mode and exclusive mode, we would see that they conflict with each other. So you might think that this is going to block. But because it's on a different table, it is not going to block. So any transaction or any operation that is operating on a different table, guaranteed not to ever block. So let's hit enter, and we can see that that doesn't block right here. Now line 7, lock table U in exclusive mode. That's happening in this session right here. So let's do lock table U in exclusive mode like that. And now here, this lock is going to happen on table U. We have another lock on table U. And so now we have to actually look up in that table whether it's going to block or not block. Again, exclusive, that's the hint that it's going to block with everything. And so I'll hit enter right here, and we see that it does in fact block. I think in the instructions, it's asking you to circle any of the transactions like this that block. And now table 8 down here, lock table T in row share mode. So here we have row share, and we're going against table T, not table U. Up here, table T is in share mode. So this is one that even I have to look up, like, okay, does share and row share conflict? So let's go over to our documentation. And this again is in the explicit locking documentation, where we have this table right here. And our existing lock mode is the one that happened first. So line 4 happened first. Table T is in share mode. So existing is share. Our new one is row share. Over here, existing is share right here. And then our new one is row share coming across. There's no block right here. So this is going to not block. It should just work fine. So let's try it out. Lock table T in row share mode like that. And let's hit enter, and it does not, in fact, block. And then, oh, maybe this was your question. It looks like I have a, nope, that's not a typo. This is, then on line 9 over here, we have our, oh, sorry. Yeah, so then the question is line 9 over here, it's saying that we should be committing, and we're not actually able to type things in over here because it's blocked still. And so this, yes, this is a typo. This, we're supposed to commit on session 2 before committing on session 1. So commit session 2, and then commit session 1 like this. So this commit supposed to be right there. This commit supposed to be down 1 like that.
Can you do it before in session 1? I think I tried and it still worked.
Yeah, so the question is, can you do it? Yeah, so the, let's see. So on the quiz, I don't want to have a weird situation like this. So I will promise to be a little bit more careful on the quiz. Yeah, technically, so the way to think about this is that, like on line 9, we try to run the commit command. It's not able to run it yet because we're still blocked on this one. And so we try to run it. Basically, let's go ahead and reproduce that situation where we're blocked. So begin, block table T in share mode. And then down over here, begin, lock table U in exclusive mode, lock table U in exclusive mode, lock table T in share mode. So now we're on line 9, and I could type commit right here, and this commit that I just typed in, it's sort of like in the queue waiting to be processed by this pSQL session. And but it's not yet able to actually run it because we're still waiting on line 7 to complete. And then as soon over here as I type commit, this is going to instantly cause this line to commit and this line to finish. And then the commit right here, because it's in the queue, it will also instantly be run. So I hit this, and then we can see that, okay, it instantly ran the commit as well. Yeah, maybe not technically a typo, but not something that I was intending for you to have to deal with. Does that answer your question there?
Would it make sense to say that the commit in session 1 was also blocked?
Good question. So the question was, is this commit also blocked in session 1? The answer is no, that the commits did not get run until the block on line 7 was released. And then the commit did not end up, the commit itself ran without blocking. It would be possible for this to block and then this to run instantly and block as well, if more complex stuff was going on here, but that doesn't happen to be the case. Good question. Any other questions about that or anything up to the deadlock section? Okay. So more examples. And then here's where, in my opinion, things start getting hairy for the first time, is the implicit locks. That the stuff is weird up until this. It's different than other things that we've seen in programming. But here is where it's, I don't know, I think if you understand the rules, you're able to follow the rules, then you can get everything up to this port just fine. Here's where it's really easy to make mistakes with implicit locks. And what an implicit lock is that every command in SQL has some lock level that's associated with it. So like the insert right here has a lock level that's associated with it. And it's going to automatically run the associated lock. So the way that you figure out what the lock associated with the command is back in the documentation over here above the table. Every one of these lock levels has 2 paragraphs. The first paragraph just basically describing the table. I never even look at this. The table is much easier to read than this paragraph. But the second paragraph tells you exactly what commands are associated with that particular lock level. And so if we were to look at the row exclusive, we would find that the commands update, delete, and insert acquire this lock mode on the target table. And so here, when we have this insert, it's also applying a row exclusive right here. And try one more time with this pen. There we go, it does work now. Okay. So this insert right here, applying the row exclusive lock. And so now this problem, now that we know that it's a row exclusive lock, is just like the problem that we had before. And if we look up in the table, we would see that the access exclusive conflicts with the row exclusive. And so this right here is going to block. There's another way to figure out. So this is how far we got up to last time. And now we're going to talk about another way to figure out exactly what locks a particular command will take. That navigating this documentation can be, I don't know, potentially confusing. But this is what you're going to have available on the quiz. So this is what you should get used to using. But a way that you can check your work, check your understanding of this documentation, is Postgres has a built-in table called pglocks. So I'll do \d pglocks. So this top connection to pSQL up here, let's get rid of that, make some more room, is going to be where we're working with this pglocks table, and so we can just visualize what the locks are that are happening at any given time. There's a lot of stuff. Let me move this over here. Make it a little bit easier to read. There we go. Not quite. So there's a lot of stuff in this relation, this pglocks relation. And what we're most interested in right here, this relation column, tells us what exactly is the table that's being locked. And then this mode tells us what is the mode that the table's been locked in. And then there's a lot of other things that Postgres uses internally, which at this point, at least, we don't care about. And so I'm going to do a select relation, comma, mode from pg_locks like this. And internally in Postgres, every relation, everything is what's called an OID. And an OID is just a number. In order to convert this into something that's a little bit easier to read, we can do : reg class like this. Relation : reg class. Recall that this right here is a cast operation using the sort of syntax popular for math, converting the relation OID into the reg class type. And a reg class is just the actual like printed name of the table. So here we have a lock on the pglocks relation, and it's an access share lock. Turns out that when I'm doing this select statement right here, if we were to look at the documentation again, we would see that every select statement results in an access share lock on the underlying table. So pglocks, you will always see when you look at it, an access share lock on pglocks. This empty one right here, I want to look at one more column in this table for a second. This lock type column. Select lock type comma relation. There's in Postgres, there are many different types of things that can be locked. Relation, again, is like a table. So this is the one that we care about at this point. XID, X stands for transaction. So this is a virtual transaction ID. We don't care about these at this point, so we'll just be thinking about relations. So let's add a where lock type equals relation like this to our little debugging statement. And now we're just going to get a list of all the tables that have a lock on them and what their actual lock is. So this particular command right here is going to be a useful one to just check your understanding of what's actually being locked at any given time. Okay, but let's see, before I reformat my screen, any questions about this command at this point? Okay. We'll actually see some examples of how that's useful next. Move it up here. So now up at top, here's where that same command is right there. And now, let's see, let's reset all of these, make it a little bit nicer to look at. Run our pSQL. There we go. And what I'm going to do, let's just do a begin right here. Lock T in exclusive mode like that. Lock table up here, run it. And now we can see that we have T locked with an exclusive lock right here. So this was maybe obvious because we did it explicitly like this. Let's go ahead and abort that transaction. But now if we begin, and if we use a new command like analyze T, and we don't know what analyze T does yet. We don't care what analyze T does yet. All we care about is what kind of lock does analyze create on our table at this point. And we should figure that out by looking at the documentation over here, maybe doing a control F for analyze. And we would see here's the word analyze right here. And under the share update exclusive lock. And so that's our hypothesis, is that we've just created a share update exclusive lock. Let's come over here and check that. And there we go, share update exclusive lock. So that's how you can double check that you are reading the documentation correctly. And if you're like in the middle of one of these complicated problems and you think that the locks should look a certain way, this will tell you exactly what the locks look like. Any questions about that? How to use this debugging relation up here, or how analyze caused a share update exclusive lock? John?
One command is going to correspond to exactly one lock, right?
At this point, one command corresponds to one lock. By the end of the document, one command could correspond to an arbitrary number of locks on an arbitrary number of tables. So, yes. Good question. Any other questions so far? Okay, yeah.
By the way, if we change the line 3 in session 1 to be like in source statement, will the line 4 be dropped?
So you're saying, okay, what if we had an insert statement, like insert into T values 3, something like that. Now up here, we run this and we can see on T, we have a row exclusive lock. And because if we looked in the documentation, that's what we would see corresponds to the insert statement. So again, this is a good way to double check your work, but don't use this as a crutch, because on your quiz, you will not be able to have access to Postgres at all. You'll have access to the documentation, but you will not be allowed to connect to the Postgres server. So you won't be able to run something like this to check what command corresponds to what lock level. Okay, yeah, so this first implicit locks, on the left-hand side, I'm just giving you the explicit lock, and then the right-hand side, something implicit, where you have to figure out what type of lock is going to happen. And so there's a number of these problems that I'll let you work on your own. And then implicit locks 2 over here, the difference is that now there's these sort of weird commands on the right-hand side, so creating index and vacuuming and this analyze. And then implicit locks 3, now there's nothing explicit anywhere, everything is implicit. So on the left-hand side, we have this insert T, and we know that this is a row exclusive lock based on what we just saw right here, row exclusive corresponding to insert. So we have row exclusive here and row exclusive here. Let's look up in our table. Row exclusive does not conflict with row exclusive. Come down here to the actual table to see that. Our existing lock mode is row exclusive right there. And trying to acquire a row exclusive, that is allowed to do. So nothing on this problem will block. Again, the problem here, the difficulty is just taking these insert statements and going back to what are the locks. And then once you do that, it's the same as the previous problems. Any questions on anything so far? Okay. So this, I ordered things, I think, in a slightly bad way. Let's see, so yeah, everything we've seen so far at this point has been basically a review of last time, except this debugging thing is new. Here, we're gonna start new material, but we're gonna skip section 8, go to section 9, and then come back to section 8. So section 9, implicit locks on the row level. So up here, everything that we've looked at so far has been in this documentation, this table level locks. And what we're going to look at next is the row level locks right here. So again, you're responsible for both of these two things. A table level lock applies to the entire table, and a row level lock is something that applies only to an individual row at a time. Yeah, so let's go ahead and do this problem 37 right here. Just gonna make sure that we have a clean database before we do. Drop table U. Okay, there's no relations anywhere, so we have a clean database. And let's prep our database with these first 4 commands over here. So create table T a int like that, and insert into T values 1, and then 2, and then 3. So we just ran these first 4 commands right here. Now session 2, we'll do a begin like that, and session or line 6 over here, another begin, and then update T, set a equals 6, where a equals 1 like that, and hit enter. And let's go ahead and cheat and check out what kind of lock that creates at the table level like this. This debugging command up here will only ever tell us what the table level locks are. It will never tell us what the row level locks are. And so this has created a table level lock called the row exclusive lock. And then on line 8 over here, so let's do an update T, set a equals 7, where a equals 1, like so. And we can see that we get this, this blocking behavior. So why are we getting this blocking behavior? Intuitively, what's happening is that here on the left-hand side, we're trying to set a particular we're trying to update the table over here and setting some value to 6 where a equals 1. And now over here, we're trying to figure out, like, are we, how to say this? In order to know whether we can complete this command right here, complete this 8 command, setting a equals 7 where a equals 1, we have to know whether this command right here succeeded or didn't succeed. If this command succeeded, then there is no row to update over here. If this command failed, then there is a row to update. So if up here I do an abort like this, we roll back, and then down here, select star from T. We've updated the 1 to a 7 like that. Let's go ahead and abort this. And then up here, let's redo this, begin. Do that, update, begin. Oops, and I did that in the wrong order. So at this point, I've star from T. So we have T has 1, 2, and 3. We've completed these first 4 lines right here, and we're on line 5. Let's begin. In the bottom session is the second session. Begin right here. So that begin corresponds to line 5. Line 6, begin up here. And then our update T set a equals 6, where a equals 1, like so. And then on line 8, update T set a equals 7, where a equals 1, like so. Last time I aborted, and we saw that that caused this update to actually happen. Now this time, let's do a commit up here. And now when we commit up here, we see that this stops the block down here, but it says update 0 because no update actually happened. Let's go ahead and commit down here too, and to do a select star from T. And we can see that we have 2, 3, and 6 instead of 2, 3, and 7. So whether this line right here takes any effect will depend on whether this line right here takes effect. And whether this line right here takes effect depends on whether this line down here is a commit or an abort. Are there any questions so far about that? Question, Tone?
At the bottom, or you just switch it, right? I mean, the one with the one, right?
Sorry, can you say that again?
Sorry, I thought one insert first, and now like at the bottom.
At the bottom? I don't know what you're referring to.
Why isn't it 6, 2, 3? Yeah.
Oh, the question is the order?
Yeah.
So recall that when you have a select statement, if you don't have an order by, then Postgres gets to determine the order arbitrarily based on what it finds convenient. Next week, we will be talking about like the actual internal details of like what is going on algorithmically with all of this. And we will see why it turns out that 2, 3, 6 happens to be convenient for Postgres in this case. Yeah, order is arbitrary when there's no order by clause. So for the problems, one of the things that it asks you to do is if there's a select statement, actually like print out what the output of the select statement is. The select statements all just have like order doesn't apply to any of the select statements. So something like this isn't something that you have to consider. Good question. Yeah. Karen.
So if line 10 in session 1 was abort, then it would be 2, 3, 7, not 2, 3, 6.
Exactly, and so that's the what we did first is that here this was an abort. I think I don't know, somewhere in here there's an example like that actually typed out. But if this is an abort, then this happens, and so we have 2, 3, 7. If this is a commit, this does not happen. Technically, it still happens. It just there is nothing with an a equals 1, so it doesn't take any effect. And so that's why we get 2, 3, 6 with commit, 2, 3, 7 with abort. Did that answer your question?
Yeah.
Dustin?
Because line 7 is a row level block. He did line 8 on the where clause where a equals 2. That would not apply.
Great question. So the question is, how does like the row impact this? And so let's go ahead and give us a clean slate to start from here. So there's no relations, no relations. Let's do the first few lines up here. Create table T, a int, like that. Insert into T values 1, 2, 3. Down here begin, so we're on line 5 right now. Just did line 5 begin in session 2, line 6 begin up here, and then our update T set A equals 6, where A equals 1 like this. And we know this is a row level block because up here the mode says row exclusive. We don't know which row it is from this. We just know that it is on some row. But the row that's being blocked is whatever rows satisfy this condition right here. And so down here, if we were to change this to say update T, set A equals 7, where A equals 2. Now this is a different row that's being applied to. And so this does not block against this because it's 2 separate rows. Now, if we were to go ahead and commit both of these and select star from T, and we get that both of those changed. Question, Joey?
Yeah, so line 8 is the way it is currently in line 8 is a row level block.
So yes, I'm not sure what you mean by the way it is currently, though. What are you referring to by that?
Instead of like where A is 2, so like the way it is in the column.
So the I'm calling these row level blocks right here because the type of table lock contains this word row. Anytime the type of the table lock contains this word row, it means there is a stronger lock on an individual row somewhere. There, so down here, if we go to the row level locks, there's this list of 4 different types of locks that can exist on a row level lock, and it will explain what they are down here. And there's another similar table right here for how they conflict with each other. But I think for the most part, like the explanations down here are much more confusing than is like I think than is needed. Yeah, you should refer to that. You should try to understand it. But here it's like it's because it's the same row. That's why it's blocking. And if it's a different row, it's applying to a totally different thing. It's not affecting at all. And so that's why it's not blocking. I don't know, did that answer?
Yeah, I guess I was like just the answer to this question, line 8 is the block.
Oh, so then yes, for the way it's written right now, the answer to this question, you would, oh, what happened? You would circle that it's blocking. Yeah. Question, Kim?
So the reason why line 7 runs before line 8 is a block, right? But like if line 8 was like.
Well, let's pause that for a second. So the reason why line 7 runs before line 8 is just because it's written before line 8 in this case.
But like since line 9 commits session 2 first, would it still run before if line 8 wasn't?
Okay, I see your question. This is related to the question that Dustin asked earlier at the beginning of the class with one of the previous questions about the order of the commits. That yeah, this I should have put this commit first and this commit down here second. So technically what's happening is that this is blocking. So even though you type in commit down here on the second session, it's not able to run this commit until this happens. And so you're right that this line 10 commit will happen before the line 9 commit.
And in like if line 8 wasn't blocked at all, it was just a complete row. and you committed it first, then that does happen first before session 1 starts and you commit it later.
Exactly. So the question is, let's say that this A equals 1 was actually A equals 2. Then now this and this both at the table level give us the row exclusive lock, but it's two separate rows being locked. And so this one is able to proceed where this one is not able to proceed. And so, or sorry, they're both able to proceed. And so there's no lock right here. And this 9 commit happens instantly. And then the 10 commit will happen after that. Good questions. Yeah, all fantastic questions so far. Any other questions?
Professor, I asked a question in the chat, but I'm just gonna repeat it.
Yeah, I can't see the chat, so go ahead and.
Okay, so I was asking why is it the symbol? Is it because of the where clause where like the A equal 1? Because you mentioned that. Why, like you just spoke about how it's not inserting because of like the thing being the same row, and I was just wondering if it's because of the where clause A equal 1 that line number 7.
The question is why are these two conflicting right here? Why are they affecting the same row? And the answer is that it is in fact because of this where clause. The where clause condition matches in both cases, and so that's why there's a conflict. One of the subtleties of these update statements is I want to see what happens when there is no where clause in the update statement. So let's go ahead and get ourselves back to a drop table T. There we go, no relations. So we're at the very beginning of this problem. Create table T, A, int, like that. And then insert into T values 1, 2, 3. And down here, begin. So that was line 5, now line 6. Begin, now line 7. Update T, set A equals 6, where A equals 1, like this. This has a row exclusive lock just on this one particular row right here. But now on line 8, I'm going to change line 8 in this next example, so there is no where clause. So update T, set A equals 7, like this. The only difference between this example that I'm doing right now and the one already typed up here is that there is no where clause that I've typed in down here. This is confusing. This is not something that anybody would ever do on purpose in practice, but this is an extremely common typo that people accidentally type in. And whenever there's no where clause, it's the equivalent of having where true, so applying to every row. And so here there are some rows that have the lock on them and some of the rows that do not have the lock on them. And because some of the rows have a lock, it's going to block like this. If any of the rows have a conflicting lock, it's going to cause the block. So here, no where clause means it applies to all rows. One of those rows, A equals 1, happens to have a lock on it. And so that's going to cause this to block down here. Any questions about that, Dustin? Yeah, so commit. Let's go ahead and commit both. Select star from G, and everything is 7. Yeah, all great questions so far. Any other questions about this row exclusive lock created by the update command? Kieran.
And so why is it not 1 or like 6, 7, 7?
Yeah, question is why is it not, so here we have 777, why is it not 677? So we have an update right here setting it equal to 6. Here we have an update setting things equal to 7. And let's say here update set A equals 6 where A equals 1. So this will only happen when A equals 1. If this happens first, nothing will be A equals 1. So this will happen but have no effect. If this happens first, then the command that I ran down here will overwrite whatever happened. So no matter what the order between this update right here and this update right here, it'll happen to be the case that everything is 7. Yeah, good questions. Maybe if you weren't feeling confused at the stuff yesterday, maybe this is starting to feel like getting into difficult problem territory. And we're only halfway done with the notes, so more excitement ahead. The question is, if I ran this first, would this cause a block on this right here? The answer is yes. That will. Okay, so drop table T. Create table T A int tables. So I'm just starting everything from scratch. Insert into T values 1, 2, 3. Then down here, begin. And your question was, I believe, if I first do the update T set A equals 7 down here, will this cause a block up here on the, update T set A equals 6, where A equals 1? And the answer is that yes, it will block. The reason is because this command depends on whether this command happens or doesn't happen. If I abort, then this command is going to do something. Then if I commit, we already saw what happens if I commit. So let's go ahead and abort. Commit this one up here and select star from T like this, and we get the 2, 3, 3, 6. Okay, I want to keep moving on. All great questions, and playing around with these other examples will help, I think, just get a feel and clarify these. What I want for us to go take a look at next, though, is this problem 44, where it says the select star from T where A equals 2, this for update right here. So for update is introducing a new syntax that is so this is a syntax that is important for the quiz. This is a syntax that people use all the time, and so very important. But this is one of the few things in this document that's not actually needed for the next programming assignment. So I think you should try to understand it, but if there's something that you have to skip understanding, this is the thing to skip. So the select statement by default creates no row level locks. But if you add this for update, then it does create a row level lock. And in particular, it creates this for update row level lock. And if we read this, we will say that it will tell us that it's going to block anything else essentially that happens to that row, except reads from the same transaction. And so let's go ahead and drop table T, redo everything, create table T a int, insert into T values 1, 2, 3, then line 5, begin right here, line 6 up here, begin. And now select star from T where A equals 2 for update, like this. That's what's different over here. Hit enter. And now, because it said for update, it's going to block subsequent updates. Update T, set A equals 7, where A equals 2, and that blocks. I'm gonna abort both of these transactions, abort, abort, redo this, begin. Run the select without a for update, so just an ordinary select. Now down here, begin, does not block. So the short answer here is that the for update is going to cause things like updates on that. Anything that affects this row, so like a delete as well, will cause those to block. Besides for update, there are these other things that so for key share, for no key update that I could put right here. These have, well, let's see. Internally, they're used by Postgres for various consistency checks. For updates, the one that's like the only one that I've actually ever seen people use in practice as like at the application level. So this is the only one that's going to happen on the quiz. You can rest assured that these ones down here will not happen on the quiz, and just the for update. Any last questions on these row level locks at all? Karen? This was on 44, yes. So line 8 does in fact block on problem 44. If I were to give you problem 44 without this for update, then line 8 would not block and you would not circle it. But because it has for update, we will circle that. Yes. Yeah, so the question is like, what's the application for this? The answer is that let's say we have we're a bank, and at the very beginning of some block of code, we need to get the amount of money in the account, but later on we might need to update that. We would want to block that for update because we're going to update it later, and we don't want the amount of money in the bank account to change between the time when we first look at it and later on when we actually need to use it. Yeah, that's like the classic. For most of these locks, the classic examples involve like bank accounts somehow, and those documentations will go through like, here's the bank account application for this particular thing. Did that answer your question? Okay. The next section down here, isolation levels 2. So recall that the isolation levels, there's 2 different documentation pages that you're responsible for. So far, we've only been looking at the explicit locking today. Last time, we also, however, looked at this transaction isolation, and you're responsible for both of these 2 sections right here. The repeatable read isolation level, the difference between that is that if we read a row once, we're always guaranteed to get that same result with the repeatable read isolation level. Whereas with the read committed isolation level, we're not guaranteed to get that same result. For this isolation levels 2 problem, this is checking what is the interaction between these isolation levels and these row level commits, these row level locks. And so that's why this is happening at this location in the notes. And I'm not going to actually go over this in class, but these examples here come straight from the documentation. You'll see that there are certain situations that cause an error message. So you're responsible for looking up in the documentation about what is that situation that causes the error message. Are there any questions about that, what you're expected to do? Joy?
So isolation level 2 is fair game for the quiz.
Is very what?
Fair game for the quiz.
Fair game for the quiz. Okay. So at this point, we've talked about, well, in databases, there's this sort of famous thing, ACID. Postgres is an ACID database. Every SQL database is an ACID database. And we've talked about the atomicity and the isolation, the A and the I. Next, we're going to talk about the consistency, the C. And the consistency involves things like unique constraints and foreign key constraints. And I don't think we're going to finish that fully today. So we will finish that on Monday, but we'll see how far we can get today. So let's come back up here to the, there we go, the unique constraints section. Again, I did that a little bit out of order. And I also, this here is a typo that instead of saying exclusive lock right here, this is supposed to just say the row exclusive lock. And I'm going to walk through this example, and we're going to see like just what exactly is a little bit weird about this example. So let's go ahead and get ourselves into a plain state back here. And so the difference here, we know we have a unique constraint because in the table definition up here, it has the word unique in the table definition. So create table T, A, int, unique, like that. Create table. And then begin and insert into T values 5, insert into T values 5, like this. And then on the right-hand side, we have our begin and an insert into T value 6. And because these numbers here don't conflict with each other, everything's going to work fine. Insert into T values 6. No problems right here. If I come up here, rerun this, you'll see that we have row exclusive locks on the T table, one for this insertion right here, and one for this insertion right here. And then, yeah, we'll go ahead and commit both of these. So at this point, like this unique constraint hasn't done anything special because these two values didn't match. But what happens if these values were to match? So what happens if we had another problem? Let's see, I don't want to overwrite that one. I'm going to overwrite this one. Here I originally had a null. Let's change this null to a 6 though. So what happens if I try to insert the same thing in both tables? So drop table T, create table T, A, int, unique, begin, insert into T values 6 right here, and then right down here, begin, insert into T values 6. You'll see that it still blocks, or that it, not still blocks, it does block. Up here, there was no block because the values did not match. We had the row exclusive lock on each of the rows that we insert into the table. And so, yeah, row exclusive lock on 5, row exclusive lock on 6. Here we have a row exclusive lock on 6, and now we have another row exclusive lock on 6. And whether this transaction right here is allowed to complete or is going to error will depend on whether this transaction right here commits or aborts. If we were to commit right here, then there will be a 6 in the database, and so this is not allowed to happen. Commit up here. There is a 6 in the database now, and so we get this error message. So we can cross out this line right here, get an error message that's not allowed to happen because of this right here. Thanks. In addition to the error message, I also forgot to circle it because it does in fact block. So it first blocks, then on the commit, it gets the error message. So it's a circle and an X right here. Are there any questions about how that unique constraint is working?
I was just wondering, I felt like the changes in my one transaction like were not occurring. The other transaction, how do we know how
Yeah, it's a good question. So the question is, changes in one transaction are supposed to be isolated from the other transactions until the commit actually happens. And so, so what's going on here? In some way, this is maybe a leak in the abstraction because we could potentially check whether that there's another transaction that's inserted this 6 by checking to see whether the statement right here blocks. Turns out it's not actually possible, though, to check whether a statement has blocked or not. So in that sense, it is still totally isolated from each other. But yeah, that is maybe some like a weakness or a limitation of that isolation, is that blocks can still happen. It's just you can't have a select or something that's actually taking advantage of that knowledge somehow. It's a great question, though. Sorry?
So if session 2 were to commit before session 1, would there be an error on line 3 then?
So the question is, what if session 2 were to commit before session 1? And the answer is that the way this is written, session 2 cannot commit before session 1 because line 7 right here is going to block. And so even if we had a commit immediately afterwards, that commit's not going to happen until the block is released by committing session 1. So implementation-wise, thinking a little bit more carefully about what's going on here, every unique constraint corresponds to, when we do the insertion, we add a, let me write this out. We have the row exclusive lock on the inserted row. But we also, in order to know whether we conflict with something else, we also have a select statement that gets run on that particular row. And so that select statement is, this is the thing that's going to be the part that's actually blocking on, that's actually blocking right here, that the insertion is okay, and anything that blocks a select statement is going to block this line right here. At this point, that is a subtlety that's not important. The important thing is that these things block. But next class, we'll see how this select statement is actually important. And it turns out that you can delay this select statement until the actual commit time down here. And that's going to be super important for our homework assignment this coming week, is delaying these checks until the convenient time, until the actual commit, so that we can get our data inserted without blocking or deadlocks. So that is a good stopping spot for us today. We've made it everything through our the first set of notes. This new set of notes, though, is not, we haven't touched that at all. And so we'll go over that on Monday. And yeah, hope you all have a great weekend. See you on Monday.
Thank you, Mike.